is 1, and then T2 means MPLS TTL is 1. Okay, the packet is sent to R2. R2 drops the packet. Why? Because the packet, the MPLS TTL decreases to 0. Because of that, R2 discards the packet and sends back an ICMP error message. You can see this ICMP error message. I want to write this here because it's better for us to understand the process. Let's change the value to ICMP, okay? And here, look at here, ICMP. Let's check it. Okay, in the first capture, here's the first capture. Okay, you can see that 10121 sends the packet to quad 5 and it received an ICMP error message, time to leave exceeded, from 10122 to the 10121. Because of this error message, R1 can understand, can learn the first hop, that is R2. Okay, now check to other captures. Look at the other captures. Here you can see error message, and in R3 you can see here, yes, error message. And here in the link between R4 and R5 you can see error message. Why? You know the reason, but I want to talk about this. Okay, again, this is so important. Because of that, we should carefully analyze the concepts. Look at here. This is the activity happened. First, R1, we should draw similar scenario, R2, R3, and R4, and finally R5. Okay, this is our scenario. Very good. R1 sends the packet. We sends the original data packet, UDP, and then IPTTL. IPTTL is 1. Okay, and also MPLS TTL, because the link between R1 and R2 use MPLS TTL to 1. The packet reaches to R2, and here this packet is discarded. R2 should send an error message, but it can't send back to R1. It should send the packet, the error message packet, toward the destination of the packet, of the original packet. You know that the destination of original packet is quad 5. Okay, and the source is 192.168.150. Okay, this is the source IP of packet 150. I use IP1. IP1 means the source of packet. Okay, this is the IP of R1. It's easier. IP1. The packet, this is the original packet. The packet is sent from the R2, should have the source IP of received interface, the interface that received the original packet. That is the 10.122. Okay, and destination of this ICMP error message is to 10. This is IP1. IP1 here. IP1. Why? Because finally it should reach to the IP1. And the packet originated in R2. Because of this, IPTTL is 255. And also MPLS TTL is 255. Okay? Maybe you ask me how R2 understand that, what is the outgoing interface for this traffic? The outgoing interface for this traffic is same as the outgoing interface for the original traffic. What does this mean? Okay, we should talk about this. You know that from first video, we have quad 5/32 here, and all of the routers such as R1, R2, R3, R4, and R5 should choose a label for this network. For example, R1 use local label as 100 for these networks, and also maybe R2 use 200 for these networks, and R3 use 300, and R4 use 400. Okay, 400 local label, but R5 use null label. You know that R5 doesn't select a label for this network. We can check it. Let's check it. In R1, show MPLS LDP binding for quad 5, quad 255. Okay, let's do this in all of the routers. R1, R1, then R2, then R3, and R4, and finally R5. Okay, now we have in R1 100 as a local label, in R2 200, in R3 300, in R4 400, and in R5 null. Okay, it's correct. And you know that every router should send its label to other neighbors. For example, R1 sends its label to R2, and R2 also sends its label to R1 and R3. Because of that, R1 receives from R2 label 200, and R2 receives from R1 label 100, and also from R3 label 300. Okay, and in R3 receives from R2 200 and received from R4 400, and again in R4 received from R3 300 and from R5 null. Okay, and finally in R5 received from R4 400. Okay, and when the packet from R1 should send to the quad 5, it uses its next stop label. The next stop label is the label that is received from the next stop. You know that the next stop label for this network is 200. Because of that, in the MPLS label, it uses 200 as a label with TTL1. When the packet reaches to R2 and R2 drops the packets or discards the packet, the original packet now is discarded. But an error message packet, ICMP error packet, should send normally same as the original packet. This means that it should receive the 200 and change it to the 300. This is the label of next stop. Because of that, the label swaps to 300 and the packet sent. When this packet, this error message packet receives with R3 should sense this packet. The source IP and destination IP is same. The IP TTL doesn't change. But MPLS TTL has an active role. In MPLS TTL first, we change the label from 300 to the next stop label, 400. And after that, TTL decreased to 254. Okay? And then the packet received to R4. When packet receives to R4, R4 sends the packets unchanged in the IP header, unchanged in the IP TTL, okay, here. And MPLS label should change. The label, this label should be popped because it receives null from next stop, and TTL should be decreased to 253. And finally, after popping this label, the TTL value copies in the IPTTL.